MOLE16 looking at parts per million. Now parts per million is almost exactly the same as weight percent, except we're timesing by a million rather than timesing by 100. But all the same rules apply. Make sure your two masses are in the same units, and then just take that ratio and times by a million. So the first part of the question, well, before we do that, let's have a look at what the equation is going to be. And also, please change D in your booklets. I should have said mass of acetic acid, so please correct that in your booklets. So for all these questions, we're going to use the formula parts per million of substance X equals the mass of X divided by the mass of the mixture times by 1 million, where mass of the mixture is the total mass of the solute plus solvent mixture, and it's usually just going to be approximately equal to the solvent, because usually when we use parts per million, that's because the mass of X is very, very, very small, therefore it's not going to affect the mass of the mixture all that much. So sometimes you might see some textbooks and some sources just summarizing the mass of the mixture as to being just the mass of the solvent. So let's look at part A. We've been asked to find the parts per million of strontium in a 450 gram firework that contains 0.5 grams of strontium. Well, in that case, the mass of the strontium is 0.5 grams, and I've said the mass of the mixture is 450 grams, mainly because the 0.5 grams of strontium is inside the firework. It says the 450 gram firework contains that 0.5 grams of strontium, so that's already taken into account in that whole mass. So the parts per million of strontium will just be the mass of strontium, 0.5, divided by the mass of the mixture, 450, times a million, gives us 1,111.1, which rounded off to one significant figure, because 0.5 grams is one significant figure. That gives us 1,000 parts per million. Moving on to part B, the parts per million lithium in a 250 milligram tablet that contains 150 micrograms of lithium. So we've been given the mass of lithium, which is 150 micrograms, and the mass of the mixture, which is the tablet, which contains lithium, so it's 250 milligrams. So they are now. But don't forget, we've got to use them same units if we're going to use this formula. So let's convert them both to grams. It's nice and easy to do, because to convert to grams, all you've got to do is replace the prefix here with its corresponding number. So that becomes 150 times 10 to the minus 6 grams for lithium, and for the mixture becomes 250 times 10 to the minus 3 grams. Writing that out in scientific notation, that's 1.5 which is 10 to the minus 4 grams for lithium, and just 0.25 grams for the mixture. So now we can go to the parts per million lithium is just going to be the mass of lithium, which is 1.5 with 10 to the minus 4 grams, divided by the mass of the mixture, 0.25 grams, times a million. That gives us 600. And this is where it gets a little bit tricky, because look at our question. We've got two significant figures and two significant figures. Therefore, our answer needs to be in two significant figures, but our answer comes out to be only one significant figure. And this is where scientific notation comes in handy, because by using scientific notation, all the numbers before the times sign here are significant. So this 6 and this 0 are both significant. Times 10 to the 2 is not considered significant, but that's how you can write 600 to two significant figures. 6.0 times 10 to the 2, and that's in parts per million. Looking at part C, the mass of tantalum in 1 ton of scrap steel, if it's 0.02 parts per million tantalum. Well, the mass of the tantalum is what we're trying to find. We know the mass of the mixture, the steel scrap, is 1 ton, and the parts per million tantalum is 0.02. So we can substitute that into our formula. For the parts per million, we're going to put 0.02. The mass of tantalum we don't know, but the total mass is 1 ton of steel. It's very important whether we use 1 ton there, times a million. We can go ahead and rearrange that, and it turns out the mass of tantalum is just 0.02 divided by a million. And we get that number, we get 2 by 10 to the minus 8. But don't forget, that's going to come out in tons, because in these parts per million calculations, whatever unit you use here, you must use here. If one of these is your unknown, whatever unit you put in will be the unit of the answer you get. So that's 2 by 10 to the minus 8 tons. You could rewrite that as just 0.02 grams though if you wish. Part D of 16, just remember to change that question in your notes. We've got to find the mass of acetic acid in a 100 kiloliter tank of sauce if it's 575 parts per million acetic acid. So the data, we are trying to find the mass of acetic acid. We know the volume of the sauce, which I've written down here as volume of water, is 100 kiloliters, and the parts per million acetic acid is 575. The reason I've assumed that sauce is 100 kiloliters of water, not sauce, is to use this equation here, the parts per million equation. We've got to make sure both these are masses and they're both in the same units. So we've got to somehow convert this 100 kiloliter tank into a mass. We can only do that if we pretend it's water, because we know that the water, 1 litre equals 1 kilogram. So we can replace this 100 kiloliters with 100 times 10 to the 3 litres, because that kiloliters means times 10 to the 3. And then we can say, well, 1 litre equals 1 kilogram. The mass of water must be 100 times 10 to the 3 kilograms. So now we can start substituting. All I've done here is put 575 in for the parts per million. I've left, that should be the mass of acetic, should be here, because we're trying to find the mass of acetic, divided by the mass of the solution, which is 100 times 10 to the 3 kilograms. Don't forget it's kilograms, times by a million. Rearranging that, we get the 575 divided by that million is equal to the mass of acetic divided by 100 times 10 to the 3, or the mass of acetic acid is just 100 times 10 to the 3 times 575 divided by a million. That gives me 57.5, which to one significant figure, which is what this number is, rounds off to 60, but that's going to be in kilograms because I kept the mass of my water in kilograms.